All right, in this video, we're going to talk about mental multiplication and the times tables. Basically, how can we think about multiplication in our head, really understanding what it is, and how can we use that understanding to help us learn the times tables. So let's start by looking at a simple expression of multiplication, 4 times 3. Okay, the first thing I want to say is that when we see this multiplication sign, we can almost think about it as reading like groups of. Okay, so if we see 4 times 3, that's 4 groups of 3. So another way that I could write that then would be 3 plus another 3 plus another 3 plus another 3. Right? I have how many groups of 3 that I'm combining together? 4 of them. So multiplication is really just adding the same number over and over and over again. Repeated addition. Now, another thing we should understand about multiplication is that the order that we write it in, the order that we multiply in doesn't matter. So 4 times 3 and 3 times 4 have the same value. But if we think about this as groups of, then we could also, instead of having 4 groups of 3, we could have 3 groups of 4. 4 plus 4 plus 4. Okay, but these both have the same value, which is 12. So just one other point on this. It doesn't have to be written like 3 times 4 for me to think of it like 3 groups of 4. I could look at this and understand that 4 times 3 represents this, but it also represents this, okay? Either 4 groups of 3 or 3 groups of 4. Okay, so now we're going to talk about how do we use this understanding of what multiplication actually is to help us learn our times tables more quickly, and then also to do multiplication in our heads. So first I want to focus on this concept of landmark multiples. Okay, a multiple is a number that we hit when we count by a certain number. So like when we're learning our 6 times tables, we're learning the multiples of 6. So we're going to focus on our, let's just focus on the number 6 in our 6 times tables right now. Okay, and for any number, there's some times tables that are easy to memorize and easy to learn. There's 6 times 1. Okay, or any number times 1 is just equal to itself, okay, and that should make sense to us. We either have 6 groups of 1, 6 ones, which just makes 6, or 1 group of 6. Okay, the next landmark that we're going to jump to, and this is just a pattern that we are going to learn, is our 10 times tables, right? I was talking in addition and subtraction also about our whole number system is based on 10. So that works in our advantage here as well. So 6 times 10 is 60. Okay. The other landmark that we're going to jump to, and the first times tables that we can get comfortable with, are our 5 times tables. Right? Now either, I know sometimes we feel comfortable counting by 5s, 5, 10, 15, 20, so we could do it that way, in which case I would count by 5 6 times. Or we could focus on this pattern where, okay, I know with my 10 times tables, what happens? I just add a 0, right? 6 times 10, 60. Well, what's the relationship between my 10 times tables and my 5 times tables? My 5 times tables is half of my 10, okay? And that makes sense because 5 is half of 10. Instead of 5 groups of 6, instead of 10 groups of 6, I have 5 groups of 6, so this is 30, okay? Now, let's think about, again, what this means. This is 1 group of 6. This is 5 groups of 6. So 6 plus 6 plus 6 plus 6 plus 6. And then this here, this is 10 groups of 6, right? Or if I'm counting by 6, 10 times. Okay. So these are the first times tables that we should learn for every number, right? Let's get comfortable with what does it do to a number when I multiply by 10? It adds a 0. And then from there, we can say, well, if I know 6 times 10, I can figure out 6 times 5 because it's half of it, okay? So once we have those solid, how can we build on these landmark facts, right, to then kind of extend our knowledge out, okay? It's really important when we're learning our times tables. It's going to be way easier if we understand how all these facts are connected to each other. If we're just learning, hundreds of different random facts and we just have to memorize them, it's going to seem impossible, okay? So from each of these landmarks, we can go up or down one, like 6 times tables, right? So if I know 6 times 10, I can use this to help me figure out 6 times 11, okay? How? Well, this is 10 groups of 6, or 10 sixes. That means this is just 11 sixes. So it's whatever this is plus 6, okay? So 6 times 11, 66. Now I could even build up one more from there. How do I get to 6 times 12? Well, just add another 6, okay? And we get to 72. But I could also, from 6 times 10, use that to help me figure out 6 times 9, right? Well, why? This is 9 groups of 6. This is 10 groups of 6, so if I just take away a 6, 60 minus 6 is 54, okay? Now I could do the same thing up and down from 6 times 5. If 6 times 5 is 30, 6 times 4 would be 6 less than 30, so 24. And then 6 times 6 is 36, okay? So I'm going to circle in black here the landmark numbers, or the landmark multiples, right? Our 5 times tables, our 10 times tables. And then notice how if we were comfortable with those and we had those in our head automatically, right? It's not, we don't have to memorize the whole times tables. We can then build off of that, right? And bit by bit, all of these will just become second nature. So yeah, we can use this strategy for all of our times tables. I was just using the 6s as an example. Okay, so the next thing that we're gonna talk about is how do we use the powers of 10, right? We're gonna assume that we're in a situation where I feel more comfortable with my times tables, or maybe even I have the times table chart in front of me, okay? I've written up here some of the 7 times tables, just to go over. 7 times 1 is 7. 7 times 2 is 14. Notice to get from here to here, I just add 7. Add 7. 7 times 3, 21. 7 times 4, 28. 7 times 5, 35. What I want to show you now is that if I know what 7 times 2 is, then I also know what 7 times 20 is. Okay, if 7 times 2 is 14, I don't know why I didn't put equal signs here. If 7 times 2 is equal to 14, then 7 times 20 is equal to 140. Okay, do we see this pattern here? Right? So take a second and try to think about what would 7 times 3 get you? 7 times 30. What would 7 times 40 be? And what would 7 times 50 be? Pause the video for a second. Okay? 7 times 30, 210. Times 40 is 280. And then times 50 would be 350. Okay? Notice it's just the 7 times tables, but now we have an additional 0. Okay? The digits have shifted over one place. So now that we have this understanding, how can we use this to do some like seemingly more complex multiplication problems in our head? Let's use the example of 7 times 39. Okay, like, God, how am I going to do that in my head? Well, 7 times 39 is really close to which of these multiplication facts that we actually already know the answer to, right? It's really close to 7 times 40. So if 7 times 40 is 280, what do I need to do to get from here down to 7 times 39? What's the difference, right? This is 40 groups of 7, and this is 39 groups of 7. So there's just taking away one group of 7 or 1 7, so I could just subtract, right? Now I could do this in my head, but we've also gone over the algorithm. Okay, I could borrow from the 7. 10 minus 7 is 3. Borrow from the 8. Okay, so 7 times 39, 273. Let's try one more. What about 7 times 52? Okay, what would be my landmark multiple that I could jump to in my head, right, if I knew my times tables? Well, this is kind of close to 7 times 50. I know that 7 times 5 is 35, so 7 times 50 is 350. Okay, what's the difference between 7 times 50 and 7 times 52? Just 2 more 7s. So I could take 350 plus 7 is 357. Right, again, I'm sort of just showing what I could do in my head. And then plus another 7 gets me to 364. Okay? So, just to review, in this video, we've gone over really understanding what multiplication is, right? The fact that it's repeated addition, the fact that the order we multiply in does not matter. Okay, we call that the commutative property of multiplication. We talked about landmark multiples, right? When we're trying to learn our times tables, let's learn the 1s, the 10s, and the 5s first, and then we can build off of that. Okay, and then lastly, we talked about the powers of 10, right? Once I know my times tables, once I know 7 times 3 is 21, I also know 7 times 30. Or, to take it one step further, 7 times 300. Okay, 7 times 300 is 2,100. And then additionally, right, we can bring it all together to use all of this information to more adeptly and efficiently multiply numbers like this in our head. Okay? Thank you all for watching, and I'll see you in the next one.